Okay, so wonderful good morning, everyone. I welcome you to my YouTube channel. Presenting before you this wonderful tutorial is Hambil Kliman, your mentor. And today I'm teaching you on Newton's laws of motion. And to those of you that are new to this channel, make sure that you subscribe, you hit the like button, and also don't forget to share to others so that they may also learn with you. All right, let's get into our usual business. Now, we are going to start with the first law of motion, which happens to be very interesting. Okay, it's not that bulky, but it's quite interesting. Now, the first law of motion simply states that an object moves with a velocity that is constant in magnitude and direction unless a non-zero net force acts on it. Okay, so they're saying an object moves with a velocity that is constant in magnitude and direction unless a non-zero net force acts on it. The net force on an object is defined as the vector sum of all the external forces exerted on the object. So what Newton's first law of motion simply describes of, it simply talks of an object that continues in its state of motion. Okay, an object that continues in its state of motion. Now, it simply says that that object will continue in its state of motion unless an unbalanced force or a non-zero net force is simply exerted on that force. In other words, if you are to get, for example, a ball, then you hit the ball will begin to roll on the ground. It will begin to roll on the ground. Now, what they are simply saying is that that ball will continue rolling on the ground till I don't know how many years, unless there is a net force or unless there is an external force that is exerted on it. So you discover that maybe as the ball is moving on the ground, it will experience some friction. As the ball moves on the ground, it will experience some resistance from the air. Therefore, that resistance from the ground, as well as that resistance from the air, that is simply an external force. And that external force is likely to stop the motion of that object. So in other words, it simply talks about an object that is in motion. That object, if there is no force to act on it, there is no independent force, so there is no external force, then automatically we expect that object to simply move in its way of motion. It will continuously move. It will continue the motion unless there is a force that is exerted on it. So that is simply the explanation. Now, as you are able to see, we have a table here. Now, on that table there are books. There is this book. Now, the illustration is that there are certain forces that are acting on this book. It is very important to be very sharp at imagination, because when you look at this book, there is a force which is simply moving this side, because we have been told that this book has its velocity or speed in this direction. Okay, so this book is moving in this direction. That is where the speed is pointing this direction. But then, as this ball is moving in this direction, there is a force which is acting on this book, such that this force is pulling this side, because it wants this book to remain at its initial point or at its point of rest. Okay, so this is a resistant force. Therefore, you expect as you push this book, of course, it will make a little bit of some motion in this direction like this, but at some point you expect the book to stop. Why? Because there is a force this side which is acting on it, which we are calling as the non-zero force or the unbalanced force. Now, another thing that you need to know the summation of all the forces that are acting on this book. There is a force due to this direction. There is also a force due to this direction. There is a force due to this direction. There is also a force due to this direction. Now, all the forces that are acting on this book are what we call the net force. Net simply means summation of everything. When we put everything together, we come up with what we are calling as the net force. So here they're saying first law applied. When a net force is applied, the velocity changes. In other words, when you apply a force on this book, you expect a change in velocity. Why? Because the more force you apply on this one, the more the book is likely to accelerate at a high speed. Okay? The more likely the book will move at a speed which is very high. No wonder why they are saying that the more force you apply, okay, the more the velocity changes. So in other words, you understand that force and velocity are directly proportional. Okay, at some point they've got a very good relationship. Okay, now when you look at this one, the direction is in this side and there is no force that is acting due to this direction. Therefore, this book doesn't have, there is no friction. This is frictionless. There is no friction here. Therefore, there is no force to pull this book this side. So if you push this book this side, because there is no force acting, okay, in this direction, you expect this book to continue in its state of motion. Okay, it will continue in its state of motion to, I don't know, okay, till I don't know, but it will continue in its state of motion. And there won't be a change in velocity. The velocity will be maintained. Why? Because there is no net force acting in either of the directions. Okay, let's get to the second law of motion. Now here they're saying that the acceleration A of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In other words, see, acceleration is directly proportional to the net force. I'm going to explain what this simply means and you'll be able to understand. Okay? So the acceleration is directly proportional to the net force which is acting on it. Now it is inversely proportional to its mass. Now imagine pushing a block of ice across a frictionless horizontal surface. Okay? When you exert some horizontal force on the block, it moves with an acceleration of say 2 meters per second. Now if you apply a force twice as large as the acceleration in the first place, then automatically you expect this acceleration to double. So it's going to double from 2 meters per second. In other words, imagine you are pushing a car, okay? You discover that the more you push that car, the more the car is accelerating. The more you push the vehicle, the more the vehicle is accelerating. The higher you push it, the higher the speed. Okay, the higher you push it, the higher the speed. So now, if you push it at a high force, then you discover that the speed also changes, or the rate at which it accelerates will also change. You expect it to simply double, or it's going to become at least twice the first velocity that you had, the first acceleration that you had applied. Okay, so if you apply an acceleration of this, you expect this guy to double. If you apply, if you apply a force which is doubled compared to the first force. Okay, but then a car, or let me say an object, is made up of some mass, right? An object is made up of some mass. But then maybe let me try to explain this using a diagram. Now, we have a formula here where they are saying this is simply the summation of all forces. What are they saying when they say the force is directly proportional? The force itself is directly proportional to the mass and the acceleration. Why do we say so? It's because when you're pushing an object, remember that object has got mass. and at the same time that object is accelerating. It's feeling some acceleration. Therefore, force is directly proportional to both the mass and the acceleration. Now, there is a point we raised here. We're saying that the acceleration of an object is directly proportional to the net force and inversely proportional to its mass. Now, what do we mean by that? Okay. Here we are able, if we keep the mass constant, we are going to have something like this. Force is equal to, let's keep the mass constant, meaning it's going to disappear. It's going to be 1. Then you discover that you're going to have acceleration here. Okay? Have you seen what's happening? So you discover that the force is as directly proportional to the acceleration. So if mass became constant, then automatically, actually mass doesn't change, it's constant. Then automatically this is directly proportional to this. So force is directly proportional to the acceleration. The more force you apply on an object, the more the object accelerates. Now let's look at the relationship that is between acceleration and mass. If we have this equal to ma, let's try to make acceleration the subject of the formula. Okay? Then we're going to have F over m. Now, if we keep the force, we say let it become constant, then automatically we're going to have something like this. Okay? Now, this simply means that the acceleration is inversely proportional to the mass, because this is inverse. Okay? This is just the same as acceleration is equals to m, like this. Have you seen? So this is an inverse relationship. In other words, the more the acceleration, the more the mass, the less the car is going to accelerate. So if a car is too heavy, no matter how you push it, it won't accelerate to the extent that you want it to accelerate to. Okay? Okay, so I'm sure you've seen what's happening here. Now, coming to this object, we have a diagram here. So I'm sure you are able to see this relationship now demonstrated. If the acceleration, if the force is in this direction, then automatically you expect the acceleration to also be in this direction. Now, it's going to depend, because summation of all forces can either be in the x, it can also either be in the y. So summation of all forces in the x is going to equal to, the mass doesn't change, but the acceleration is going to change. So it's accelerating in the x, therefore we say x here. This is the summation of all forces in the y direction, therefore the mass won't change, but the acceleration is going to be in the y. Okay? The acceleration is going to be in the y. We have a very, very nice question here. Let's try to apply something here. An airboat with mass of 3.5 multiplied by 10 is 350 kg, including the passenger, has an engine that produces a net horizontal force of that after accounting for forces of resistance. Find the acceleration of the airboat. All right, this is very, very simple, but we are going to do this question together. The first thing to do is simply to write the data. Now, this airboat has got a mass of 350. Yeah, this is 350 kg. Then we are told that it has a horizontal force, or a force in the x, of 770 newtons. Now they are saying that we find the acceleration. So the acceleration we know that the summation of all forces in the X is equal to MA. Therefore, M is simply 350, A is simply 770, like this. So if we multiply 350 multiplied by 770, we are going to have something like we're going to have something like 2,690, something like that. All right. Okay, so we're going to put that in standard form so that at least we suit them. Or maybe I just write as it is. Just wanted to write it in some standard form. Let's just write it in this way so that we don't confuse anyone. Okay, don't get confused. All right, so this is going to be 3.5 multiplied by 10 to the power 2. So 3.5 multiplied by 10 to the power 2, then 7.7 multiplied by 10 to the power 2. Same. Okay, so we're going to have 1, 2, 3, 4, 5. So 2.7 multiplied by 10 to the power wait a minute. Oh my God, what am I doing? Thank goodness. Okay, so of course we wrote the formula. It was summation of all forces is equal to, in the X it was equal to the MA. Okay, the MA. We want to find the acceleration, so it's going to be over M. So this is going to be acceleration equal to the summation of all forces in the X over the mass. Now let's do the needful. This is going to be acceleration equal to, what is the force? Of course, the force was 770 newtons over 350 kg. The acceleration is going to equal to 770 divided by 350. We're going to have a 2.2 meters per second squared. So that is the acceleration. That's the acceleration, 2.2 meters per second. Now we go to B. Starting from rest, how long does it take the airboat to reach the speed of that? How long does it take? They want us to find the time. Now to find the time, we know that the velocity is equal to AT plus VO. Okay. Now, this is just the same as over T because this is 0. This is over A, so that this and this will cancel. When the two cancels, we're going to have the time of V over A. So time is going to equal to, what is the V according to the data? We didn't even finish writing the data because we were told that the velocity is simply 12.0 meters per second. So we're going to put our 12.0 here with an acceleration of 2.2. Therefore, we say 12 divided by 2.2. We are going to have a time of 5.45 seconds. Okay, so this is how you apply Newton's second law of motion. I'm sure you are able to see how easy it is to do this. Then they are saying, after reaching that speed, the pilot turns off the engine and drifts to a stop over a distance of that. Find the resistance force, assuming it's constant. They want us to find the resisting force. Now we know that V squared is equal to VO squared plus 2AX. Now this is 0, so therefore this is going to be negative VO squared equal to 2AX. We want to find the acceleration, so it's to be 2x over 2x. So this and that will cancel. We're going to have acceleration equal to negative v squared over 2x. Now this is going to be negative, this is going to be 12 squared over 2, this is 50. So this is going to be A is equal to negative 144 over 100. Acceleration. Okay, so this is going to be 1.44 meters per second squared. It's a negative. After we find this, we can introduce Newton's second law of motion, which simply states that the summation of all forces is equal to the MA. Now, the summation of all forces, which happens to be the resistance, is going to equal to, what is the mass? Remember, the mass doesn't change. It is 350 kg. The acceleration is still the same, negative 1.44 is to the needful multiplied by 350. Of course, we're going to find 504 newtons. That's the resistance force. You expect even more resistance, right? Okay, so this is simply it. I'm sure you've learned something here. All right, let's get to third law of motion. Now, what about the third law of motion? What is it all about? What is Newton's third law of motion all about? Okay, since we discussed first law, what is the third law of motion all about? Now, the third law of motion simply states that the action force is equal in magnitude to the reaction force and opposite in direction. In all cases, the action and reaction forces act on different objects. So Newton's third law of motion is also known as the action, reaction, but in opposite direction forces. In other words, this is simply where the heart of this topic is. Because if, for example, let's say, for example, you have a ball here. Okay? You have a ball here. If you are standing here, okay? You are standing here, then you hit this ball at this point, okay? Then you are exerting a force in this direction. There is a force you are exerting in this direction, but at the same time, there is a force this ball is exerting on you in this direction. Okay? Now, if you exert, for example, a force of 50 newtons on this ball, then automatically the ball is going also to exert a force of 50 newtons on you. But your force is in this direction, so it's going to be negative 50 newtons because it's in this direction. Okay? It's a force in this direction. Not that the force is negative, but it is in this direction, the negative direction. Then the ball is going to exert a positive force. okay, in the other direction. No wonder why they are saying the two forces must be equal in magnitude, but the directions must be opposite. In other words, this one must go this side, the other one must go this side. Okay? That's the reason as to why if you are involved in a road accident, you bash in a tree. Okay, you bash in a tree. This is a tree. This is a car that has bashed in a tree. So if a car hit into a tree, let's say it exerts a force in this direction of 1,000 newtons. The force is in this direction. Okay? It is same as the tree has also exerted a force on the car of 1,000 newtons in this direction. So it is same as the tree has also hit you. It's also exerted a force, its own force on the car. No wonder why people die. Why? Because the force that you exert on the tree is the force the tree also exerts on you. So as you are able to see here, we have this block here. Now this block has been placed on top of this table. Now there are forces that you must be familiar with that are acting on this table. Okay? That are acting on this table and the object. The first thing that we're able to see is a box which is on top of this table. Now this box, remember, it's experiencing some gravity. Okay? It's experiencing some gravity. At the same time, there is a force which is acting from this point upward where there's space. So now, this force which is acting upward is simply what we are calling as the normal force. Okay, so let me write. Force acting upward is called the normal force. Okay, the force acting upward is also known as the normal force. Now this normal force, remember, there is a contact in between this table and the box on top. So what we're simply saying is that this normal force, it's called the normal force because it's perpendicular to this line here. Like normal ray, light, physics, light, grade 12 physics, light, normal ray, it comes like this. Okay? So the same way, it's coming like this, it's called the normal force. Now, remember that this force is arising as a result of some contact because of friction, okay, and contact between this table and the box itself. Therefore, we say that it is as a result of the cohesion of matter and is electromagnetic in origin. Keyword, it exists as a result of cohesion. Okay? As a result of electromagnetic in origin. Now, so there is a force due upward, which we are calling as the normal force, the force acting upward. At the same time, there is a force which is acting downward here, which we also call the normal force. But remember that this box here is on top of this table. Therefore, this box is experiencing some gravitational field force. That gravitational field force is simply the force which is acting downward here. I'm sure you've seen it. It's here. This is the force acting downward. So there is a force pulling upward, which is called the normal. provided by the table. There is also a force acting downward provided by this box. At the same time, there is a force which is acting downward like this, called the Fg, which is the gravitational field force. And there is a force that the table is also providing, which is upward, so that it may enable this box to stay. So I'm sure you've seen how these forces are acting. Okay, so let me just write for the sake of knowing. So the Fg is the force of gravity acting downward against the upward force. Okay, so I'm sure you are able to see this. So if you have a table, let's say for example you have a table like this, then this is lying on a stand. This thing here is supporting whatever is on top. So there is a force this thing is applying, which is upward, which we are calling as the normal force. Okay? At the same time, this thing here has got that affiliability to fall down so that it may reach the ground. So there is a force this guy is also exerting, which is downward here. This force is called the Fg, or the gravitational field force. Okay, gravitational field force. So you must be able to know this. You must be able to know these formulas. Okay, same as, for example, if we have two balls, we have this ball, let's name it as ball 1. We also have this ball, let's name it as ball 2. If this exerts a force on here of, let's say, 50 newtons, okay, then automatically you also expect this ball 2 to exert a force of 50 newtons here. So if there is a force which is acting upward, which we are calling as the normal force on this ball, okay, let's say it's on the table, then automatically you expect a force to act also downward, so that this force can cause this thing to go down, and this force is called the mg. No wonder why in my next video I'll be able to show you that the normal force is equal to the mg sine of the angle theta, and at the same time it can also be equal to the mg cosine of the angle theta, depending on how you've put it, okay, or how it is settled on top of the box, so or on top of an object. So you'll be able to learn all this in my next video to come. So I'm sure you've learned something, okay? So it must be equivalent to this guy here, okay? Must be equivalent to this guy here. And in some books, you'll find them write something like the normal force is equal to the negative mg sine of the angle theta. Then this negative is as a result of, it's as a result of, if you have a table like this, this is in the negative, this is the negative Fg equal to the mg, okay? So it's a result of this guy having so much affiliability to fall down, therefore it becomes negative. So this is quite easy and very interesting. So I'm sure you've learned how I've explained all this. It's very simple, just know how everything is done. All right, let's get to some other things. We have some practice question here. Some practice question, there's an application. Let's try to apply whatever we've learned here so that we see if it's going to hold or if it's going to make sense. Here they're saying a traffic light weighing 1000 newtons, that is 100 newtons. Right. Okay, so we can write the data. Okay, so according to the data, they are saying that we have a force of 100 newtons from a vertical cable tied to two other cables that are fastened to support as in figure 4.14. The upper cables makes an angle, so there is an angle theta, which we'll call theta 1, of 37.0 degrees. There is also theta 2 of 53.0 degrees. Now they're saying with the horizontal, find the tension in each of the cables. They want us to apply Newton's third law of motion to find the tension. Now, you may be asking, what is tension? Tension is simply, tension is force found in ropes, strings, or wires, or anything that has got the ability to be elastic. Okay, the tension force. So tension. So we have this traffic light here, and it's holding this thing here. This is a traffic light. It's got red, green, amber, whatever. It's a traffic light. Now they want us to apply the force. They want us to apply Newton's third law of motion in order to find the tension force due to this and due to this. So the first thing to do is simply to write this. Okay, we are going to write this. How? This can also be written as, okay, you can draw something like this, because if you do the calculations, discover that if you draw a line here, this force and this force are going to, sorry, this degree and this degree are going to be the same. Let me show you something. So if you do this, don't want to waste much time. Like this, you name this one as your tension 2. Let's call this one tension 1. Now you discover that this force, this angle, and if I draw a line here, and a line here, you discover that this and this are just the same. Okay, therefore, this can also be equal to 37 degrees. This is also 53 degrees. Okay, that's the first thing to do for you to find this question. All right, I won't draw the traffic light, you know where it is. Now I'm going to use vectors. I'm going to compute these forces into vectors, because remember that these guys are moving at an angle theta, this side at an angle theta, so we need to use vectors. Now I'm going to say forces in the x. So the force is in the x, there is a force due to this direction. If I do this, there is T x, which is equal to T2, is 2 cosine the angle 53 degrees. Then there is a force also, which is Ty equal to T2 sine 53 degrees. Sure, by now you know this after having learned vectors. So in the x, we have Tx equal to T2, then cosine 53 degrees. Okay? Then this side, remember this, there's supposed to be a 90 degrees here. Now this tells you that this is in the negative direction. Therefore, there is a force also here in this direction. The x is going to be T1 equal to negative T1 cosine 37 degrees. Okay? Then there is like this. Okay, this is supposed to be in the x. Okay, this is Tx but dealing with T1. Then there's also ty equal to, now for Ty we are talking of this force, Tx. Now Ty is in the positive direction, therefore we say Ty is equal to T to be positive because it's going upward. So it will be T1 sine positive 37 degrees. So we're going to have another Tx equal to negative T1 cosine 37 degrees. Then we can also say forces in the y. Now the forces in the y are Ty is equal to T2 sine 53 degrees. Then we're going to have Ty equal to T1 which is sine 37 degrees. Now when we reach here, what do? We can now add all the forces in the x. Let's try to add. So to add the forces in the x, we're going to say that T2 cosine 53 degrees minus, because this is a negative, T1 cosine 37 degrees. This must equal to 0. Okay? This must equal to 0. Then this is just the same as T2 cosine 53 degrees must equal to T1 cosine 37 degrees. Okay? Now, here we can make T2 the subject by simply cancelling, and we make cosine 53 degrees cosine 53 degrees. So this is going to be T2 is going to equal to, let's try to do the needful. It's going to equal to T1 1.327. Let's name this as equation 1. Okay? We can name this as equation 1. So we've done the needful. Okay. Wow, very interesting. Let's do the second one. Now we are going to combine the forces in the y. To combine the forces in the y, we'll say that we have T2 sine 53 plus T1 sine 37 degrees. Now remember that this must be subtracted because this thing has some force which is trying to pull it downward. So consider that force because we are given, and that force is simply because they said it was weighing. Okay, they said that it was weighing, meaning that's the weight, meaning it's acting downward, it's negative. So we subtract it. So it will be minus 100 Newton, then this must equal 0. Meaning this is going to be T2 sine 53 plus T1 sine 37 degrees. This must equal to 100. Now, this is just the same as T2. What is sine 53? Sine 53 is going to equal to sine 53 will equal 0.7986 sake of accuracy plus T1 sine 37, it will equal to sine 37 is going to equal to 0.60, then equal to 100. Okay, now when you reach here, what do? You are going to say that since we have T2 equal to this, so where there is T2, we're going to replace with this expression. So it's going to become T1 1.327, okay, 0.986 plus T1. This must equal 100. Now, when you check, you discover that we have everything now in T1 and T1, and it's going to be easy like that. So you do multiply 1.327. Let's multiply it with 0.7986. Okay, we are going to have something like T1 equal to 1.0597 plus T1 equal to 0.60, like this. Then you can add the two. If you add the two, we are going to have something like 1.659 T1 equal to 100 over 1.659 over 1.659. So therefore T1 is equal to, so say 100 divided by the answer, we're going to have a 60.2 newtons. So that's the tension one. That's the tension here. This is the force which was put in this rope for this guy to be balanced. This was the tension in this rope. Now let's try to find tension 2. For tension 2, which happens to be here, I think everything is done here. We can just say that T2 is equal to, T1 has already been found, it's 60.2, 1.327. Then T2 is going to equal to, this is 60 multiplied by 1.327. The answer is simply 79.9 newtons. This was the tension in the other rope, this one. So for these guys to be balanced, we were supposed to have a tension in this rope of 79.9 newtons and a tension in this rope of 60.2 newtons. Then everything is going to be balanced. So this is how you solve this question. It's quite easy. It's quite easy. This is how you solve this question. So if you have a question, you have not understood of everything that I've done here, then automatically you can inbox me. These are my details, and I'll be able to respond to you. So make sure that you understand what I have taught. Make sure that you understand what I have taught. Make sure that you get the concept. This is very easy. So now in our next video tutorial, I'll be showing you how you do as many questions as you can under this topic. As many questions as you can under this topic, I'll be able to show you. And to those of you that are new to this channel, these are my details. Make sure that you inbox me. You inbox on this line if you have a question. And also don't forget to subscribe so that you'll be able to receive every video notification of everything that I'll be able to do. So physics is very easy. It's very simple. You just have to apply the concepts that are given to you. you apply the needful concepts, you apply the needful things that are really needed, and you'll be able to understand everything. So thank you so much. Shalom, shalom.